Okay, good afternoon. So, theory of light. Sa theory of light, uh, basig di lang ni nako ma-discuss tanan, no? Kay taas man kayo ang kuan jud slide akong na himo. Then ang air transportation nato is nagkakuan na lang. Nagka Martes akong i-discuss. Then there is a air transportation na theory of light. So ang subject code ani sa AMT, mga AMT is AMT 114. Then wako kay ba unsa ning subject code para sa IBM. Then mao to taas kayo ang slide, so basig din ako takol tanan. So basig putlon lang ako, din self learning lang ang uban ninyo. Kay mag-quiz pa mapud ko kung hapit na ang time. So mao to. Then sa kaning theory of light nga topic is makaver na to ang sections of an airplane. So mao to na primary lima ka primary structure sa eroplano. So mao ni ang fuselage, wings, empennage, power plant, and landing gear. Then ato pong matakol ning control surfaces, ang aerofoil, definitions of terms sa kaning mga parts, uban nga words nga makuha na to, masugatan later on. Then the four forces of flight is matakol po na nato. Then the three axes of flight, stability, stalls, spins, spiral dives, load factor, then kaning pitot tube or static system or instrument nga magamit diri sa Cessna 150 or ubang type of aircraft. So first, the airplane. So nay duha ka types sa airplane. So mo ni ang aeroplane and kaning aircraft. So ako lang paspason kay gamay ra kayo atong time, then hapit na ang ato ang final exam. So aeroplane is a power driven, heavier than air. This aircraft deriving its lift in flight from aerodynamic reactions on surfaces that remain fixed under given conditions of flight. So ang ikaduha is aircraft. So any machine that are capable of deriving support in the atmosphere from reactions with the air. So motto, inote lang ninyo nga ang aeroplane is an aircraft, but an aircraft is not always an aeroplane. Then other aircraft, so morning airship, helicopter, balloon, glider, or ultralight, unsa pa man, blimps, mayana. So aircraft pud na siya. Naiduha ka categories ang aircraft. So ang lighter than air or mao nang aerostats, and heavier than air aircraft or aerodyne. So sa aerostats, ang example ani is airship, balloon, blimps. Then sa kaning heavier than air, mao ning mga aircraft nga mag-need og engine. So helicopter, glider, glider is as an example of heavier than air pod. Then kanang Boeing, mga de Havilland Bombardier, unsa pa man, jet, mga jets mga jets day. Then parts of an airplane. So the essential components or primary structure of an airplane are lima kabok primary structure of an airplane. So mao ni ang fuselage, then wings kaning green color, then kaning fuselage is kaning yellow color, ang power plant is kaning orange color, makita lang sa illustration. Then empennage is nasa likod or kaning tail section sa aeroplano. Then landing gear is ang wheels and tires niya. So dira pinaka support sa gravity sa structure sa aeroplano. So mao ni ang landing gear. Then sa fuselage, mao ni ang central body, then accommodates crew, passengers, and cargo. So gamay ra man ang mapansaka na ning cargo. Then part ani which the other components are attached to. So mao to ang wings, power plant, ang landing gear o empennage kay gi-attach sa fuselage. Then construction types of fuselage is truss type and monocoque and semi-monocoque. Then sa truss type, longerons and girders, waring trusses for a frame. Then mao to sa frame man niya. Ako lang ipakita pohon kung magka-laboratory mga ganito. Then fabric ani nga gamiton in is composite. Then napoy i-apply nga metal or metal for the covering. Mura aluminum man siguro or steel sheet. Then sa monocoque, stringers, formers, bulkheads for carrying the loads. Then skin to carry some of the loads too. Then semi-monocoque is when stiffeners are provided to carry some of the load. Next, sa empennage. Kaning empennage is an arrangement of stabilizing surfaces at the tail of an aircraft. So parts ani na upat ka parts, daghan jud ay parts diyan pero ang kanang kuan lang murag dakog bahin sa tail. So morning ang parts niya sa empennage is the horizontal stabilizer, elevator, vertical stabilizer, and last kay rudder. So kanang each sa elevator and rudder naman na siya trim tabs pero wala na ako gi butang dire. So pohon kuan ra ninyo matakol ra ni sa aircraft structure. Then wings. Wings is an airfoil that helps lift a heavier than air aircraft when positioned above the fuselage. So mao ni ang high wings that provide an unrestricted view below and good lateral stability. So kaning high wings kay naman ni sa positioning. Sa positioning of wing, so naay tulo ka classification for or tulo ka types. So high wing, mid wing, then low wing. So makita lang ninyo sa illustration kung asa naka locate ang each wing sa any type of positioning. Then configurations po sa wings is biplane. So duha ka wing straight na siya, nasa high wing and nasa low wing. Then ang monoplane is isa lang na lang siya sa, so it's either kuanday high wing, mid wing, or low wing kung monoplane. Then next sa wings, so international construction, so spars, ribs, compression struts, then anti-drag wires. So daghan pa gyapon kanang mga parts sa internal construction. So kung unsa lang akong gi butang dire sa akong slide is mao lang pud ang akong hatag nga quiz or activity pohon kung maapil magani siya. So di na ko kinahanglan tong ubang answer nga wala diri sa slide. Then external construction is kaning ailerons, flaps, wing struts, engine cowl. So kaning engine cowl mao ni cover sa engine ni more sa power plant. Then wingspan is maximum distance from wing tip to wing tip. Then ang leading edge kay naman siya sa front of the wing. Kung facing ka sa aeroplano or facing ka sa nose area sa aeroplano, mo to imo makita ang kaning ihang pinaka front sa wings is tawag ana is leading edge. Then ang trailing edge is ang nasa likod or ang rear edge of the wing. Then chord line is an imaginary straight line joining the leading edge and trailing edge. The next, airfoil. So airfoil is a structure with curved surfaces designed to give the most favorable ratio of lift to drag in flight. Then it is used also as the basic form of the wings, fins, and horizontal stabilizer of most aircraft. So kaning airfoil, napod ni siya many different types of designs, each of specific purpose. Kaning basically sa kaning aircraft design for slow speeds will have a thick wing. Then ang thin wing is best for high speed. So kaning makabantay masagiro mo or nakakita ba mo jet plain. So nipis man kay niyang wing surfaces or kaniyang airfoil. So mao to, paspas lang kayo ni or kaning sa steel plane. So kanang nipis. Then next, so naay duha ka types of airfoil. So mao ni ang conventional and laminar flow. So sa conventional, so thick iyang structure and lower weight for better stall. So characteristic ani niya. And the thickest part is at 25% sa cord. So from 25%, kintahay dire sa trailing edge niya. So 25% ana is kaning mao ni thickest part niya. Then plus 25 pagyud ana, so ma 50% is mao lang gyapon ni ang iyahang thickest part niya. Ang pinaka last nga 25% is padung na trailing edge. So panipis na antod kuan iyang trailing edge. Agto na siya sa trailing edge niya. Dayon ang laminar flow is usually thin. So originally designed to fly faster. So the leading edge ani is more pointed and its lower and upper surfaces are nearly symmetrical. So ang thickest part ani is na siya sa center or sa 50% nga cord. Then wings. So aspect ratio niya. So pag kuha sa aspect ratio is wingspan over cord line. So naman po niya siya diri. AR equals BC. So tanawon lang ninyo ang diagram diri. Then ang aspect ratio is other features of the platform are often used to predict the aerodynamic efficiency of a wing because the lift to drag ratio increases with respect or the aspect ratio, improving the fuel economy in powered airplanes and the gliding angle of sail plane. So, nakuanda ang tide. Wingspan. So wingspan is the maximum extent across the wings. So mao to wingtip to wingtip. So mao nang wingspan. Then cord line, leading edge to trailing edge. So the imaginary straight line joining the leading edge and trailing edge of an airfoil or airfoil. Then landing gear. Landing gear absorb shock of landing. Then support the weight of the aircraft. Then it also enable aircraft to move around on the ground. Then types, duha ka types sa landing gear. It's either fixed and retractable. So ang fixed is kaparas ani conventional and tricycle type. Nga makita ninyo sa illustration ha. Then ang retractable is ma-retract siya or mahipos para less drag. So mas maayo kung kuan kanang retractable ang landing gear kay less drag. Then configuration na pwede ka configuration sa landing gear. So mao ni ang tricycle type and conventional or trail dragger. So as you can see sa illustration, ang conventional is duha sa main ni duha yang main pero nasa likod or sa tail section iyang isa ka wheel. Then sa tricycle type is nasa power plant or sa nose area iyang isa ka wheel, then duha pud sa main landing gear or sa likod ana niya. The next power plant or kaning propulsion system. So sa power plant, and in simple terms, an aircraft power plant is an engine. It is made up of many components such as cylinders, pistons, and fans, which help to produce the energy needed to propel an aircraft. Then the power plant may be a jet engine or combination of propellers and engine. Additionally, there are numerous types of engines for the variety of aircraft, so such as helicopters or commercial jets, commercial aircraft. Then jet engines are typically one of the more common types of aircraft power plant. So jet engines diri na makita nimo sa mga big airline, big aircraft day. mo to usually dira lang makita nato kay di kay ta kuan diri sa military pod. Then general aviation aircraft today use a gasoline. So general aviation ang gamit ani nila is naman mga Beechcraft. So usually gamit nila is gasoline powered or ang ilahang gasolinaan ang tawag ana is avgas. Which is air cooled internal combustion engine which drives a 2 or 3 bladed propeller. Then summary. So from kuan kanang page 2 sa slide hantod sa page 14. So summary lang ani is ang airplane na duha ka kuan classification. So mao to ang aeroplane and aircraft. Then primary structure sa airplane is nay katong 5 primary structures of fuselage, landing gear, power plant, wings, and empennage. So ang empennage nasa tail section. Then 3 construction type of fuselage. So mao ni ang truss type, then monocoque and semi-monocoque. Then parts of empennage section. So mao ni ang horizontal stabilizer, vertical stabilizer or fin, straight nga fin, then elevator and rudder. Then sa wings configuration, so na duha ka configuration din, monoplane and biplane. Positioning of wings, so makuan ra ni siya, applicable ra ni siya sa monotype or monoplane nga configuration of wings. So naitulo, high wing, mid wing and low wing. So next kay internal constructions of wings. So akong gibutang lang diri is mga main parts. So spars, ribs, compression strut, drag or anti-drag wires. Then external construction sa wings is kaning ailerons, flaps, wing struts, and engine cowl. Then types of wing airfoil, na duha ka buok types ani. Name ana is conventional and laminar flow. Then ang pagkuha sa aspect ratio is wingspan over or divide sa average nga chord line. Then types landing gear, so duha ka types, mao to ang fixed and retractable landing gear. So sa fixed kay kuan siya kana more drag. Then kung installan siya fairing, so mo less ang drag. Then kung retractable gani nga landing gear is mas mo less gyud ang drag kay wa may makasugat sa hangin or drag mo to. Then configuration of landing gear, mao ni ang tricycle and conventional or kaning tail dragger. So sa tricycle nasa nose landing gear, nasa nose area iyahang isa ka landing gear and nasa likod ang main landing gear ana, or sa body niya. Then ang kaning conventional or kaning tail dragger di ay ang isa ka tail niya is nasa ang isa ka wheel is nasa tail area. Then ang duha ka wheel or nagsupport sa structural loads sa eroplano is nasa wing strut dapit. So dira naka kuan position iyahang landing gear or katong duha ka main landing gear. Then power plant is an engine. Then kung namoy pangutana is mangutana na lang mo after na lang sa mahuman. After na lang mahuman ang akong discussion. Kay taas-taas pa man kuan pa man So kanis ka 60 ni nga slide, so napatay pila man. Mga 80 or 90 man siguro ka slides. Then next, there are 4 forces acting on the aircraft, mao ni ang thrust, drag, lift, and weight. Understanding how these forces work and knowing how to control them with the use of power and flight controls are essential sa flight. So thrust is the forward force produced by the power plant or kaning propeller sa aeroplano. It opposes or overcomes the force of drag. And drag is naa siya sa rearward retarding force caused by the disruption of airflow by the wing, rotor, fuselage, or kung unsa mang mga objects nga mo protrude. Then lift is a force that produced by the dynamic effect of the air acting sa airfoil and acts perpendicular to the flight path through the center of the leaf and perpendicular pod siya sa lateral nga axis. And level flight, so ang leaf is naka-oppose siya sa downward force sa or kaning gitawag nato nga wave. So as you can see naman po sa illustration po, no? Then and last is the weight. Weight is the combined load of the aircraft itself, the crew, the fuel, and the cargo or kaning mga baggage kung naman ginaibot nga baggage sa eroplano. Then weight is a force that pulls the aircraft downward because of the force of gravity. Then it opposes also sa lift and acts vertically downward through the aircraft center of gravity. Then later on matako raman pud ni nato. Di lang jud nako explain kay nagdali ta nagapas na tagyapas nga oras. The next is camber. This camber is the curvature of the upper or lower surface of the wing. Then there is a middle of the camber is ang imaginary nga chord line from the leading edge to the trailing edge of the wing. Then next is angle of attack. Angle of attack which form between the chord line and the relative airflow. Next, relative airflow. So relative airflow is the direction in which the air is moving relative to the chord of the wing. The flight path and relative airflow are always parallel pero naka-oppose. Center of pressure. So this is the point on the wing where all lift acts through. Next, laminar airflow. This is the smooth streamlined airflow over the wing. It is also defined in which the interbody of air within a designated space is uniform in both velocity and direction. So kung magsakay man gani eroplano, so smooth lang ang dagan or ang kanang flight sa eroplano kung makaagi man gani ang laminar airflow. Then turbulent airflow. This is an airflow over the wing which is no longer smooth but has become chaotic. So kung nakasakay na mo sa commercial na aircraft, so dira ma-experience ninyo or kung nakadungog mo na mga ganianing term na turbulence, then sa mid-air ana kung ma-occur man gani ni ang kaning turbulent nga airflow is mura siya mag-agi mo og rough road kung may example man gani nato sa kung magsakay mo og sakyanan. Then transition point. This is the point where the laminar airflow changes to turbulent airflow. So for example, above 10,000 feet sea level, kay smooth ra kaayo ang lupad sa eroplano, then nikalit lang turbulence, kay niagi magpanganod or nikalit lang transition from smooth to chaotic na experience sa flight. Then boundary layer. This is the very thin layer of air that stick to the wings due to skin friction. This is the layer of air consists of the laminar and turbulent airflow. Then separation point. This is the point at which the boundary layer pulls away from the wing. Mean chord. This chord is the average chord of the wing, maotong from leading edge to trailing edge. Chord line man pud to matawag sa. Next, angle of incidence. Angle of incidence is the angle at which the wing is permanently inclined to the longitudinal axis. Wash in, wash out is wings that are slightly twisted, causing the wing root to have a higher angle of attack. Then spoilers and dive brakes. These devices fitted into the wing to increase drag and decrease lift. Spoilers are on the top, dive brakes are on the bottom. So mura ra na siya thrust reverser kung makuha man gani nimo sa commercial aircraft. Next, wings fences. like surfaces on the upper part of the wing to control airflow, providing better slow speed, handling, and stall characteristics. Slots. Slots is auxiliary aerofoils fitted to the leading edge of the wing to improve lateral control. Slots pull out from wing at high angles of attack, pushes the turbulent airflow farther back. Then slots are air passageways built into the wing on the leading edge. At high angles of attack, the air flows through the holes and smoothing out the turbulent airflow. So besides sa spell, napailaing naka-difference aning slots and slots. So ang slots makita ninyo sa right side is kaning kuan siya, ma-retract. Then ang slots na nasa left side is fixed siya na hole na nasa leading edge. The next, lift. Lift is ang upward force na makasustain sa aircraft in flight. Lift will act through the center of pressure perpendicular to the relative wind or flight path, regardless of the angle of attack. Then there is a lift na aning Newton's 3 law of motion. So number 1 is an object when in motion tends to remain in motion. Then ang ikaduha is an external force must be applied to alter the state of motion. And ang ikatulo kay kaning for every action there is an equal but opposite reaction. So mas masabtan pa ninyo pohon kung makakuha na mong subject nga aerodynamics in nagka third year. Dili kayo ni nako ma-explain further kay mo to nagapasa sa oras. Then Bernoulli's principle is the total energy in a system remains constant. Kung one element mo increase, so the other element must decrease para mo counterbalance lang. Then air flowing over the upper surfaces sa wing kay mo accelerate para maka-catch up sa air flowing under the wing. Then kung magkapaspas ang hangin na magkaubos pod ang pressure on the bottom of the wing, the pressure will increase. Then the differential in pressure between the upper and lower surfaces of the wing is what causes the upward force. So mao ni ang gitawag nga lift. So next, downwash. Downwash is the flow of air downward towards the trailing edge of the wing. The airflow passing under the wing is deflected downward by the bottom surface of the wing. So the wing receives an upward force. Therefore, downwash contributes to lift. The next, this is the illustration of Bernoulli's principle kung asa ang velocity sa air mo increase din ang pressure kay mo decrease para ma-counterbalance ang and masabtan lang po din ninyo puhon kung magka-subject mo aerodynamics dili sa nina ko ma-explain karon kay mo to nagapasta sa atong oras. Next is Bernoulli versus Newton's law of motion. So sa Bernoulli is the total energy and a system remains constant as air velocity increases, pressure will decrease. And there is a Newton, so ang katong third law of motion, pero ma-apply gihapon tong first and second. Then for every action there is an equal and opposite reaction. The next, weight. Weight is the downward force due to gravity. Directly na ni-oppose sa lift. Then weight acts through the center of gravity. The next, thrust. Thrust is the force produced by the propeller. Dire na topic, the air is pushed backwards, causing thrust in the opposite direction. Thrust can be moving a large or of air backwards at slow speed, such as propeller, or small mass of backward at high speed, such as kaning sa commercial nga airplane, kaning turbine engine nga aircraft. The next is drag. Drag is the resistance of forward motion. So for an aircraft to maintain steady flight, there needs to be enough lift to overcome weight and enough thrust to overcome drag. Sa drag na total aircraft drag, and two major types niya kung asa ni nagka-cause og drag. Mao ni ang parasite drag and induced drag. Then sa parasite drag, this can be broken down sa duha ka type, which is interference drag and profile drag. And sa profile drag pod, under aning parasite, can be categorized into two types. Mao ni ang form drag and skin friction. And sa next slide, ara na makita ilahang mga meaning. So next, total drag. This total drag is the resistance of forward motion of an aircraft that experiences when moving through the air. Then ni siya duha ka major types. So mao ni ang induced drag and parasite drag. This induced drag is a drag caused by the parts of the aircraft which contribute to lift. Example ani is kaning wing, and sa tail area kaning elevator. Parasite drag is a drag caused by the parts of the aircraft which do not contribute to lift. Example aning parasite drag is kaning aircraft shape itself, so construction type and material niya gigamit. For instance, an airplane with a rough surface, so creates more parasite drag than one with a smooth surface. So parasite drag can be broken down into two types of drag. So maotong interference drag and profile drag. But before that, ari sa induced drag. Next, induced drag. The higher pressure on the lower surface of the wing will cause the air to flow outwards. Then the lower pressure on the upper surface will cause the air to flow inwards. Then nature needs balance. So higher pressure, air will flow to areas of low pressure to equalize para ma-counterbalance lang. Then airflow moving outwards from the bottom of the wing will curl up over the wingtip. So this drag is commonly called wingtip vortices. So murag nakakita naman mo aning wingtip vortices. So labi na kung na commercial aircraft sa langit, kung magdump gani ni ang commercial aircraft og fuel sa mid-air, kay naay mo form na duha ka line sa track o niya or kaning flight path kumbaga or inagian. So ni-occur ang wingtip vortices ani with the help of the fuel na gidump. So mas ni visible or ni mas nakita kay murag ni instant evaporate man ni ang fuel, then nahimong white cloud. So mo ninyo makita nga murag duha ka line ay nag-agi sa eroplano. So next, two types of parasite drag. Interference drag. This is a drag caused by joining two or more parts. So for example, look at where the fuselage and wing meet. Then sa kani, interference drag forms behind the trailing edge of the wing adjacent to the fuselage. Then solution ani is kanang streamline parts lang or i-contour lang ang aircraft body or round lang yan para mas less iyang drag. Then sa profile drag, this is a parasite drag which is further broken down into two types. So form drag is a profile drag which is drag caused by the shape of the aircraft. Then skin friction is a profile drag caused by the tendency of air flowing over the surface to stick to it. The next, so illustration, induced drag, so decrease the with velocity, while ang kaning parasite drag increases with velocity. Then further explanation in nanamoy aerodynamics na subject. Then for you to reduce the parasite drag, or in order nga ma-reduce ang parasite drag, so ang form nga buhaton is streamlining lang, then reduce frontal area of the aircraft. So mas maayo kung radial engines ang gamiton para around lang ang diri sa may nose area niya. Then dapat kuan lang po retractable ang landing gear para mas moles pa yun ang ihang drag. Then sa skin friction, so limpyuhan lang ang iyang aircraft, or limpyuhan lang ang katong sa wing ang skin surfaces ana niya sa aircraft. Kung na-accumulate nga ice, kay kwaon lang, or kung dirt, kwaon lang po, limpyuhan lang ni mugtarong, then butangan og wax. Then mas maayo kung flush rivets kaysa kaning round rivets or round patch kung magkuan man gani, kung mag-riveting man gani. Kay para kung flush rivets man god, kuan ra plain ra ang agi sa mga rivets. So mas kuan ra ninyo, masabtan ra ninyo pohon kung magka sheet metal nga kuan mo subject pod, so naka second year ninyo. Then sa interference drag, kung fix ang landing gear, kay dapat butangan og fairings para dagdag lang aerodynamic. Then streamlined ang design kay moto para kanang i-round shape lang ang ihang fuselage. Then next, reducing induced drag, high aspect ratio wings. So kung mas taas ihang aspect ratio, mas less ang induced drag. So adan og winglets, pwede pud adan og winglets og ground effect pud. The naay 3 ka dimensional of force, mao ni kanang sa kuan 3-dimensional force sa aircraft. So mao ni ang moments, couple and equilibrium. Pero wala na lang nako gi-include ning moments kay mao to kuan lang man, couples and equilibrium raman mo yung murag kanang mas ni stand out. So couples, when two forces are equal and opposite but parallel. A couple will cause a turning motion about an axis. Equilibrium, when two forces are equal but opposite. This means a steady state of motion. So for example, sa equilibrium, kung sa thrust and drag, so kung equal ang duha but opposite, they will be in a state of equilibrium. So if thrust is greater than drag, it will cause the aircraft to accelerate. Pero kung ang thrust gani is less than sa drag, so it will cause the aircraft to decelerate. Then sa lift and weight, when lift and weight are equal but opposite, the aircraft will be in a state of equilibrium. If lift is greater than weight, it will cause the aircraft to climb. Pero kung ang lift gani is less than sa weight, it will cause the aircraft nga mo descend. So for example, sa kaning couples pod, example aning couples diri sa drag sa thrust and drag, if drag is above thrust, the nose will turn up. Pero kung ang thrust is above sa drag, the nose will turn down. Then sa weight and lift, kung ang weight is ahead sa lift, the couple will cause the nose to turn down. Pero kung ang lift gani is ahead sa weight, the couple will cause the nose to turn up. The next, regardless of the type of aircraft, there are 3 axes upon which it can move, from left and right, forwards and backwards, and up and down. So in aviation, there are technical names ani. So mao ni ang lateral axis, longitudinal axis, and vertical axis. So refer sa table or kaning sa illustration ani nga slide. So sa longitudinal axis, ang movement niya is roll. Ang surface nga nagkontrol ani na motion is ang aileron. And kaning aileron naman sa wing wing area. And ang control input nimo ani na manual sa cabin kay ang stick or wheel control na i-turn lang nimo to left man gani or to right. Then sa lateral axis, ang movement ani niya is pitch, so controlled by the elevator na nasa tail section sa aircraft, and ang control input ani na imo i-manual sa sulod sa cabin kay ang stick or wheel control na imo ra i-pull or push, or imo rang i-move backward or inward nga na lang. Then sa vertical axis, ang movement ani niya kay yaw, then controlled by the rudder na nasa likod sa vertical stabilizer. And ang control input ani na i-manual nimo sa sulod sa cabin kay ang rudder pedals. So duha ni ka pedal sa left and right sa isa ka seat. The next, longitudinal axis. So the imaginary line which runs from the nose to the tail. Movement about this axis is known as roll, and it is produced and controlled by the ailerons too. Para ma-counterbalance lang aning longitudinal axis, so the movement of this axis is known as pitch, and it is produced and controlled by the elevator. Then sa lateral axis, this is an imaginary line running from wingtip to wingtip. So movement about this axis is known as pitch, and it is produced and controlled by the elevator. Then para ma-counterbalance lang ning lateral axis, so a movement of this axis is known as roll, and it is produced and controlled by the ailerons. Then sa vertical axis or kaning normal axis, it is an imaginary line running vertically through the center of gravity. So movement ani about this axis is known as yaw, and it is controlled by the rudder. Then movements and attitude. So movements are related to the aircraft, and attitudes are related to the horizon. Then movements are produced and controlled by kanang control to achieve an attitude. Then dere na lang takot og ang uban ani na slide is basahan na lang, then self-learn na lang kay mag-quiz ta sa kung sa atong na-cover karon para natay agi sa atong final coverage. Then don't worry na lang kay na may option akong mga quiz. So naay duha ka option man. So naay duha ka type sa quiz. So it's either nga i-take ninyo ang quiz na ni-out mo ani na meet hantod 4 PM ang due, or mo padayon mo attend ani na meet para sa virtual quiz na naay time limit lang. Maybe 10 minutes lang siguro out of 30 items. Then ang quiz is ako i-post after 2 minutes. Then pwede na mo left ang uban kung dili ganahan sa virtual quiz. Kung wala man gani pangutana ha. Then ayo lang hawa ang mga participant na brave enough na mo take sa quiz karon taud-taud. Basin na amoy pangutana lang. Then mo to kay magsugod man ko karon taud-taud.